Hi everyone, I'm going to be presenting my Catechol Oxidase experimental plan, which is going to be the relationship between the pyrus, which is the scientific name for pear, while I increase temperature over time. So the purpose of this experiment is we're going to explore the Catechol oxidase reaction rates with pears while we increase the temperature. So catechol oxidase is present in many fruits and vegetables, and its products are benzoquinone and water, which it forms melanin, which melanins are polymers that turn the fruit brown when it's exposed to air. So in a majority of chemical reactions, the rate of an enzyme reaction increases as the temperature increases, which is shown right here, and then it reaches its optimal temp. And then when there's too much temperature, which is usually after the optimal temp, the reaction rate starts to decrease and denature drastically, shown here. So I'm going to be focusing on the catechol oxidase reactions in pyrus when temperature is modified. So we are going to be increasing temperatures with these four temperatures. So we have 25 degrees Celsius, which is going to be our optimal, and it's going to be our control. And then we have 50, 75, and 100. Temperature is going to be our independent because that is what's being changed, and pyrus will be our dependent because that is what's being tested. My first hypothesis is if the temperature of a pear is increased while oxidizing, then the reaction rate will increase. My second is almost the same, except it's a little bit more built upon, where it says it will increase up to the optimal temperature and then denature, which was stated in the enzyme reactions with temperature slide. So when we're setting up the experiment, first we have to peel a pear, and we're going to weigh it, and then we're going to chop it up, and then we're going to add that chopped up pear into a blender with cold phosphate, and we will blend it until it's a very smooth consistency. And then we'll be pouring that mixture into a funnel, which is going to have a cheesecloth over it, and then the liquid will filter out and it will go into a flask. We will be using 4 tubes for 4 different temperatures, which will consist of the extract and water. So when we're testing the samples, we're going to be placing tube 1 and tube 2 in this water bath right here at 25 and 50 degrees Celsius because water baths can only go up to 60 degrees Celsius. And then tube 3 and tube 4 will be placed in this dry block at 75 and 100 degrees Celsius because dry blocks can go above 60 degrees Celsius. So this is what I got for my data. So the bar graph shows here that at 50 degrees Celsius, the reaction rates increase the most over time. So since at 50 degrees Celsius, the reaction rates increase with increasing temperature, which will make it the optimal temperature, because after the rest of the reaction rates, they keep increasing, but only like slightly, about 0.001 over 10 minutes, when they should be denaturing, but they just keep increasing. So I learned that reaction rates do increase with increasing temp, but only until the optimal temp, which was 50 degrees. And then I learned that my data with pyrus rates didn't decrease after optimal temp, but instead they just slowed down while increasing slightly. So that makes my second hypothesis the most accurate, but I really can't tell if my data is denaturing after optimal temperature. And then I found an article that had an experiment with pyrus and testing temperature, and their line graph showed that it did increase up to the optimal temp, but it did start to decrease drastically. And in the future, I could stick with temperature and try decreasing it instead, or I could focus on something completely different and do pH levels. So that is my video explaining my experiment. Here's my references. Thanks for watching.